Hello friends, today we will discuss about some concepts of C# programming. So here is the list of today's concept. What is garbage collector means GC in C#, what is destructor in C#, and demonstrate all with examples of garbage collector and destructor in Visual Studio. And next one is difference between garbage collector and destructor. So we will discuss all this topic with examples. So let's begin. First topic we have garbage collector means GC. So what is GC? Garbage collector in C# is used to automatically free memory by removing objects that are no longer being used by the program. So garbage collector mainly is used to free up means to release the memory which are not going to use further in our program. It automatically calls. We do not need to call it manually. It automatically calls by CLR. That is garbage collector. Suppose we have some objects which we are not going to use further in our program, so it automatically calls and releases that memory, means that object memory. So why to use this? It avoids memory leaks, no need for manual memory deletions. So it is not necessarily needed for manual memory deletion. It automatically calls and free up the memory which objects which are not going to use further. It also improves the performance by clearing unused objects. It also speed up the application performance by clearing the unused objects from that application, means the memory. So how it works, how GC works? GC tracks object references. If no references exist, memory is released automatically. So GC tracks all object references. If there is no references exist, it automatically calls and release the memory which are not going to use further. In our last lecture we saw the class examples. There we create the class and create the instance, initialize some values to variables. So that is mainly linked with the references. So it find that references, means there is so much memory which we consumed into that objects and which are not going to use further in our program. So that is automatically released by the garbage collector. So we can manually do that, but it is not recommended, because if we use these methods manually again and again, it will slow down the performance of the application. First method we have gc.collect method, forces garbage collection. So gc.collect method, what to do with this one? If we want to call this method manually, then it will forcefully call this method and check where the objects are not going to use further. In that case, it will collect all that memory data and release that memory from the objects. Next method we have gc.wait for pending finalizers method. Wait until the structures finish. So this method functionality is that it waits that this one method completes all the memory released functionality or not. So till that it will wait for that method. Next one, if we want to check in the starting of the application or in the end of the application, that in the starting what is the memory percentage, and after the execution of the program, means if we call these method, check that memory which is released with the garbage collector to check current memory usage. So here we have one example. Suppose in the starting we use this method get total memory to check what is the memory size currently we are using, and after we perform some program like we are using here for loop or for each loop, anything you can use, and after that we forcefully call this method gc.collect method manually, and after that we call this wait for pending finalizers, and at the last we call this method again to check how much memory is released from that object. So let's see this one in Visual Studio. Let's check garbage collector. In the starting we can put some message to check starting memory size. Maybe next we can use gc method, get total memory. Okay, here we can create one object, initialize one object in the instance of the object, then we can call the for loop. Next we can do this, we can put some memory into this object. Okay, next thing we can do, we can call this method garbage collector, and then we can call this wait finalizer method, that the garbage collector finishes the memory released functionality or not. Next we can check how much memory is released by the garbage collector. The memory with this same method get total memory. Next we can use read file. Okay, now let's check this one, what will be the output of this. So here we have the output. Okay, first in the starting we put this message to check what is the starting memory. So here is the starting memory 85,936, and after we execute some program where we put some value into this object, and then we call garbage collector manually with these methods, garbage collect method and wait for pending finalizers. After that we again run this same method get total memory, means how much memory is released by the garbage collector. So this is the memory released by the garbage collector. So this one is the concept of garbage collector, but this is not recommended because it is run automatically by CLR, common language runtime. So we needn't use this manually into our program, because if we use this again and again into our application, it will slow down the performance of the application. So it is not required to use this method because it is already automatically called. We do not need to call it manually. So this is all about garbage collector. Next topic we have destructor. So what is destructor? In last lecture we already discussed about constructor. Now we will discuss about destructor. A destructor is a special method in a class that is automatically called by the garbage collector when an object is no longer in use. So constructor main functionality is to create the instance, but destructor main functionality is to destroy the objects which are not used further into our application. But it is automatically called by the garbage collector, and garbage collector is automatically called by the CLR. So there is no need to do these functionalities manually because it is not recommended. But for example, we are just showing the demo, means how can we use this manually. So here is the thing, it is also used if the object is no longer used into our application, then destructor calls by the garbage collector. It is used to release unmanaged resources like file handles, database connections, network sockets, etc. So it is used to release unmanaged resources like file handles, database connections, network sockets. So here are some key points of this one. First one is features and details. Name same as that of class, prefixed with the tilde symbol. So if we want to use the destructor manually, then it has the same name of the class, and before that we have to prefix it with tilde symbol, because into with this symbol we can use the destructor with no parameters. Next one, we have no parameters allowed, so we cannot put any parameter into destructor because it is not allowed. Access modifiers is always private into this, no access modifier, it is always private. Overloading, so it is not allowed to be overload this destructor, it will be only one. Manual call, it is not allowed, runs automatically, so it is run automatically by garbage collector. Next one, we have destructor example where we create one class for this one, and where we have create one constructor, and this one is the destructor. Before class name we use this tilde symbol because to identify this one is a destructor. And next we create the instance of this class, and then we call these garbage collector methods by manually. Now let's see this one in Visual Studio. Now let's check the destructor. First we can create some class, employee class. Here we can create one constructor. Okay, we can put some message that constructor is created. As created. Okay, next thing is, if we want to create a destructor, first we have to use the tilde symbol. Okay, and next we have to put the same name as that of class, so this one is the destructor. Here we can also put some message that a destructor is called and memory is released. Is called and memory is released. Okay, so it have no parameters, we cannot put any parameters into this one. Suppose if we want to put some parameters, it is giving an error. It is not allowed into this destructor to use any parameters, and its access level is also private, so we cannot put it public, then it will also give an error. Just we have to do to use the tilde symbol with the class name if we want to use the destructor manually. Next we can create some static method with the no return type, get employee. Here we can create the instance of the constructor, means employee constructor. Okay, now the constructor is created, we can put some message here. Employees instance is created. Okay, now we can call this method here, and after that we can call garbage collector manually, which is not recommended. For only example purpose I am using this methods. Now we have the destructor example, just example. In the main method we called this static method, and in the get employee static method we create the instance of this employee class with the new keyword, means give some space, allocated space to that object. And next we call these garbage collectors manually. So first thing we have in main method every time it is called main method, as I already told you in my first or second lecture. I think you can if you didn't go through to that video, you can first saw this video for static main method. Every time it calls the main method into that application. So in here we call this get employee method, and in get employee method we create the instance of employee class. So constructor is created. So this one is the message we put into this constructor, employee constructor. So this message we put it into get employee method. Next we called this GC methods, means garbage collector methods. When it call these methods, it comes to this destructor, means the destructor is called and memory is released. So here we have this message. So this is all about the destructor. It is not recommended to call it manually. It will call automatically by garbage collector, and garbage collector is automatically called by CLR, common language runtime. Just for only example purpose of using these methods manually, because if we use these method again and again into our application, it will slow down the performance of the application. So this is all about destructor. Next we have a difference between garbage collector and destructor. So here are the features and garbage collector, GC, destructor. So what it is? Automatic memory management system, means it automatically manage the memory. Okay, means automatically release the unused objects. It is automatically called, no need to call it manually. Destructor, it is a special method in a class. If we want to create if we want to use this destructor, we have to use the tilde symbol with the class name. Next one, so what is its purpose? Freeze unmanaged memory of unused objects automatically. So it is automatically called and remove the unnecessary objects which are not going to use further. Clean up code before object is removed, mainly unmanaged resources. Same thing, means the objects which are not going to use further in our program, it removes that and release the memory. Who calls it? CLR calls it automatically. As I already told you, common language run calls it automatically, so no need to call it manually. It calls automatically by GC when objects is being destroyed. So when objects is going to being destroyed, so GC will call automatically. Control, developer cannot control when it runs, not exact time. So developer cannot control this one, because we do not know when it will calls, and if we want to call it manually, then we can do that also. Developer cannot call it manually. So same thing with this destructor also. Use case, memory cleanup, to clean up the memory and release the memory which are not going to use further. Safeguard release task if dispose not called. So what about the performance? Optimized and efficient. So when the memory is released which are not going to use further, automatically the performance is increased for the particular application. It slows performance if used too much. If used too much this destructor, then it will slow down the performance of the application, because it will consume time to remove the unnecessary objects. So what it is? Syntax. No direct syntax part of runtime. So I just gave you the examples of manually to call the garbage collector, but in the class we can use this tilde symbol with the class name and without any parameters, because it does not allow any parameters to use in destructor, or not any access modifier. Its access level is only private by default. So next one is a summary. Let's revise what we learned today. First one is a garbage collector, GC. GC automatically clears unused memory. So GC will automatically calls by CLR, and it will remove the unnecessary memory, unnecessary objects which are not going to use further. So it improves the performance and prevents memory issues. So by default it improves the performance of the application by removing the unnecessary space. In Visual Studio example, calling gc.collect method shows memory cleanup working. So we already saw this method gc.collect method, which is forcefully called by manually into Visual Studio to check if there are any objects which are not going to use further, and then it will release that objects, means that memory from that objects. Next one we have destructor. It frees unmanaged resources and called automatically by garbage collector. So destructor functionality, when objects are going to being destroyed, it calls automatically by garbage collector, and garbage collector is automatically called by CLR. No need to invoke it manually into our Visual Studio, because if we use it manually many times, it will slow down the performance, because for that it consumes time to remove the unnecessary objects. So let it invoke automatically by itself, no need to use it manually. So this is all about the garbage collector and destructor. You can practice these examples into your Visual Studio. If you have any doubt related with these topics, you can mention them into the comment section. So let's wind up today's session. Thanks. See you in the next lecture.